Good day everyone. Today, we talk about the most basic classifications. Often, terms like element, compound, and mixture. Let's unravel these concepts, appreciating the unique characteristics of each. Before we proceed, it is important to know some terms and how they look like. This how chemical look like. This one is chemical formula. This one is a chemical structure. And this one is a mixture. 1. Elements. The building blocks. Let's begin with elements. Imagine them as the most fundamental Lego bricks in the universe. An element is a pure substance that cannot be broken down into simpler substances by ordinary chemical means. Each element is defined by the number of protons in its atoms, known as its atomic number. They are the unique, unchangeable foundations from which all other matter is built. Example: gold, oxygen, and carbon. 2. Substances or pure substances, definite and uniform. When we speak of a substance in a broad chemical sense, we are referring to what's formally called a pure substance. This is matter that has a definite and uniform composition and distinct properties. Unlike mixtures, substances have specific melting points, boiling points, and densities under given conditions. Both elements and compounds fall under this umbrella of pure substances. Example 1. Sugar, commonly referred to as table sugar, is scientifically known as sucrose with a distinct and fixed chemical formula, C12H22O11. Because it has a consistent composition and uniform properties throughout, it fits the definition of a pure substance. Example 2. Table salt, sodium chloride. Every grain of pure table salt has the same chemical composition, one sodium atom for every chlorine atom, and the same distinct properties. Also, materials that are composed of same element are called substance, like oxygen gas O2 and ozone O3. 3. Compounds. Elements in union. A compound is also a pure substance, but it's formed when two or more different elements are chemically bonded together in a fixed, definite ratio. The key here is chemically bonded. When elements form a compound, they lose their individual properties and take on entirely new ones. Think of it like combining Lego bricks to build a complex model. The bricks are still there, but the model has its own distinct function and appearance. Example 1. Water, HO. Composed of hydrogen and oxygen, water has properties vastly different from either flammable hydrogen gas or reactive oxygen gas. It's a stable liquid essential for life. Example 2. Carbon dioxide, carbon dioxide. This compound, made from carbon and oxygen, is a gas vital for plant photosynthesis and a significant greenhouse gas, bearing no resemblance to solid carbon, like coal, or gaseous oxygen. 4. Mixtures. Blending without bonding. A mixture consists of two or more substances that are physically combined, not chemically bonded. Crucially, the components of a mixture retain their individual chemical identities and properties. Because there's no chemical reaction, mixtures can be separated by physical means, such as filtration, evaporation, or magnetism. A mixture can be homogeneous or heterogeneous. Example 1. Saltwater, a homogeneous mixture. When you dissolve salt in water, the salt and water molecules don't chemically react. The mixture looks uniform throughout, and you can separate the salt from the water by evaporating the water. Example 2. Sand and iron filings, a heterogeneous mixture. If you combine sand and iron filings, you can clearly see the distinct particles of both. Their properties remain unchanged, and you can easily separate the iron filings using a magnet. Understanding these distinctions is paramount to navigating the fascinating world of chemistry. Now you know the difference between element, substance, compound, and mixture. I hope you learn and enjoy. See you next time.